What we will do in this tutorial is demonstrate how to construct side-by-side stem and leaf plots. And we'll use the data that we used in the previous tutorial on stem and leaf plots, where we constructed simple stem and leaf plots. What we have here, using the same data, are going to be 80 cases, and what we have are the variable sex for each case and also their pulse in beats per minute. Now, what a side-by-side stem plot allows us to do, it allows us to plot the distribution for a quantitative variable for one category and compare that distribution to another category. And in this case, what the two categories we will be comparing will be men versus women in terms of their pulse in beats per minute for this particular sample. Scroll down to the bottom here, and I'll go down then one cell below where the data end, and I will find first of all the minimum and maximum values. The minimum value, using the min function, highlight the data range and either close parenthesis or return, and we see the minimum value is 56 beats per minute. Let's do the maximum value, and this allows us then to determine what will the stems that we'll be using, and the maximum value is 124. Now, as we demonstrated in the previous tutorial where we construct a simple stem plot, what we have to do is determine what will be our stems, and typically we go to the numeric value or numeric place that is the furthest to the left. In that case, we see the maximum value is 100. There is 124. If we choose that to be our stem, that numeric place, we would have only zeros and 1. 0 hundredths and 1 hundredths, but that's not enough variation for us for a plot. Everything would go into just two categories. So what we do then is now include the next numeric place to the right of that hundredths place, and that's going to be the tens. And now we see 50 all the way through to 120, or 5 tens up to 12 tens. Well, that's going to give us 7 or 8 categories, and that's enough for a distribution here. So let's go back up here, and what I'm going to do is first of all start to construct the stem and leaf plot. Category for the stems, which we just determined, will be the hundredths place plus the tens place rather, 5, 6 to represent 50 and 60. I'll click to drag that, and now what we have then, our stems will be from 50 up to 100, 12 tens or 120. Let me go ahead and highlight this range, and I will just simply let's see, I'll center those. Okay, what I'll do is add in the labels for the leaves, and so I'll click on cell H4 and I'll type in females, and I'll go over and click on cell F4 and type in males. Okay, now let's construct our formula for counting women who have blood pressure in the range of 50 to 59. As we showed before when constructing a simple stem and leaf plot, we'll use the repeat function equal REPT, and I want to repeat the number 0. Now we have to identify the criteria that we'll use. Now, in the past, when we used just a simple constructed just a simple stem and leaf plot, we used the Countif function. But now what we're going to do is not only ask, does someone or a case's pulse fall within the range of 50 to 59, we will also ask, and is that individual a woman? So we'll have to use the Countifs function that allows us to specify 2 criteria for selection. Open parenthesis, and I'm now going to identify the data range that we are using, where the quantitative variable is, the pulse. Once I specify the data range, now I'm going to specify the criterion for this particular data range, and I will click on cell G5, that is where the stem is, and remember that's 5 tens, so I multiply that by 10, and now what I'll do is add to that a value of 0. So if a case in the range of C2 through C81 has a value of 50, it's going to be counted towards this bin, comma, now I specify the second criterion, and that's going to be identify the data range where the other variable is listed, the variable upon which I'm categorizing or classifying these cases, and that is sex, comma, now let's specify the criterion we'll use, and in this case it's going to be female, and I put female in double quotation marks because the variable sex is entered in as a character variable. If it was entered in as a numeric variable, I would just enter in the number that corresponds to female, and close parenthesis. And now I have almost everything I need, so that's the Countifs function. Now I need to enclose that so we balance off then our parentheses for the repeat function, because here we balanced off the parentheses for the Countifs function. And if I hit enter, what you'll notice then no one falls in that range, because keep in mind we determined beforehand that the minimum value is 56, but I like to put all of the leaves in that very first formula so that way I can easily copy it down into my other cells. Now when I copy it down, what I need to do though is make sure I keep the row reference fixed, because I always want to look in C2 and C81 as well as in B2 through B81. But what I'm going to do in a moment though, once I get done constructing the stem and leaf plot for females, I'm going to then construct the same stem and leaf plot for males over the other side. And so what I also want to do is I want to make the column fixed, because I will be eventually then copying the formula over 2 columns to the left, and so I want the columns to remain fixed as well. Now in this case, the only part of this formula that will still be a relative reference is the 5 for the stem, because when I copy it down into the cells below, what you'll notice is we're still going to be using the same column, but we do want it to increment up in terms of the cell depending upon what row down we actually copied it into. And then click enter, and that then creates a formula that will allow us to copy into other cells that we have as we need fit. Now I'll do an ampersand. I don't just want to count those that have a value of 0. Whoops, let me highlight that again. Now copy, I'll put that at the end here, paste. Now what you may see, and I'll close this arrow here, you may see that initially your formula bar has only 1 row displayed. Mine had 2 because I've used this before. Now if I scroll up though in that formula bar, you notice it shows the rest of the formula. It doesn't just say we only have this part of the formula, we lost the previous part of it. But if I click on the down arrow, now I can see the entire formula and all the rows that it takes up. So now what I'll do is change this from repeat 0 to repeat 1, and then make sure that I increment that to 1. So I'll report a 1 every time a case in the range of C2 through C81 has a value of 5 times 10, which is 50 plus 1, and also in the range of B2 through B81 has a value of female. Now I will continue this as we go through, and let me just go ahead and copy the first 2 parts of this formula to the end, and all I'm going to do here is be changing then what I'm repeating. Now it's going to be a 2, and I want to make sure then if someone has a value of 2, 52 here, I'll change this to a 3, should be a value of 53, satisfy that criterion. And let me go ahead and do this a few more times. This time I will take all of those values, copy, put at the end. Now we want to make sure then that we're incrementing upwards as we want, and so let's go to the very top and read through here. This starts to get a little messy, but you'll notice then it's 0, 1, 2, 3, and now I'm starting again. This will be the second 0 before. That's where I like to go and have the first part of the formula copied to the end, because whenever I see a 0, I know then that's where I start over. Now it's going to be 4, and I modify every part of the formula that comes after then that 0. That's going to be, increment that to 5, add 5 to it. Let's go down again a little bit. This next one is going to be a 6. sure it's adding a 6 to it. This will be a 7. Add 7 to the 5 plus 10. Scroll down, see what's below there. And now what I need now are, I need 8 and 9. So I need 2 more parts of the formula. Let's go back up here. And actually what I should do is I should add the ampersand at the end before I go and copy 2 new parts of the formula. This is a little tedious, just have to be careful and patient, and I hope I've done it right. Let's copy those first 2 parts of the formula, those first 2 repeat statements. Paste, and now I know I'm going to change this last one. I want to report an 8, and I will add 5 times 10 plus 8, that's a value of 58. And this last one, I want to report a 9. That's going to be 5 times 10 plus 9. And I think that's going to do it. Let me go up and I'll just scroll through my formula to make sure, and I'll count the zeros. That's a 0 and a 0. That's a 1, and then followed by a 1. That's going to be a 2 plus 2. That's going to be a 3 plus 3. That's going to be a 4. Should come down to plus 4 right there. Next would be a 5, adding 5 to G5 times 10. The next should be a 6. There's a 6. And then that should add 6 to the 10. Repeat 7. Add a 7 to the G5 plus 10. Come down. Then we'll have an 8. Add 8 to it. And then a 9 in the situations where it's the stem, which is 5 times 10 plus 9. That looks good. I think I've got it properly constructed. Now you notice this indicates that there are no women who have pulses below 60. Let's now copy this formula all the way down, and because I used the fixed references where I did, I shouldn't have to worry now about changing then those cell references. And that's then what we see is the stem and leaf plot for women. Now let's take this first cell, let's go ahead and copy it and paste it over into F5, paste. Now you notice one thing we've got to change now. We've got to go through and change the second criterion. That is, every time we see a female, we want to make that a male. Right there. Scroll down a little bit more, change that to a male, and I think we will have a case that now falls into this bin because there's at least one individual who has a pulse in the 50 beats per minute range. Okay, so I'm just going to now scroll up through the formula, make sure that I have no females, that instead all those females have been changed to males. And I think I've got it okay. Now because I use the fixed reference for everything but the row reference in the referring to the stem, I shouldn't have to change anything else in the formula. And there we see 6s. And so there are several people then, several men, who have values of 56. Let's go ahead and copy this down, and I'm going to show you one more thing we need to go back and change. You notice now when I copy it down to the next row, it indicates that there are, and I'll click on that, and I'll make it a little bit wider for a column so we can see everything that's contained here. You notice what it reports. It reports the men who have pulse rates in the 60 beats per minute range, but it starts with 0 off to the left and ends with 8 to the right. So we go from left to right in terms of larger values for the pulse rates, which is what we want typically when we have our stems that are off to the left. But now our stems are to the right. And what we'll do instead, we want to reverse the order. So in that case, the leaves come from low to high when it's off to the right of the stem, and we want the leaves to go from low to high when it comes off to the left of the stem. So let me go ahead and delete that formula. And what we're going to come up here in the formula where the males, the very first cell, were associated with the stems of 5 for 50. I want to report the 9s first. And change the zeros to nines. Now I want to change the ones to eights. I'll change the 2 to 7. So now we're counting down instead of counting up. And what this is going to do, it's going to report then the first number that's listed in the formula is going to report it first. The second number will be reported second from the right, and so it looks like it will be the reversed order of what we see for females. Scroll down here. I want to report a 4, and let's change that to 50 plus 4. Now it's going to be a 3. 50 plus 3. It's going to be a 2. Change that 50 plus 2. And I should have done this properly, just the 9s and the 8s. That's going to be a 8. Change the 8 to a 1. And of course the criterion 8 to a 1. And then change the 9 to a 0. 9 to a 0. 50 plus 0 will give us 50. So now I'm going to go back up, and I'm going to make sure I'm counting down. 9, 9, 8, 8, 7, 7, 6, 6. I'm making sure then that the numeric value that's going to be repeated when satisfying one of these repeat functions is the same as the ones place that's being added to the criterion. 5, 5 for each one of these repeat functions. 4, 4, 3, 3, 2, 2, 1, 1, and 0, 0. That looks good. Hit enter.